Now's the perfect time to grab the 12,026 calendar and get it in time for the holidays. Our best theory of the universe could be wrong. Finally, we're going through an incredibly exciting moment. Thanks to amazing new technology, our understanding of the universe is moving faster than it has in years. And, if we're fortunate, we could be at the edge of the next revolution in the way we see the cosmos. A moment as exciting as when we first realized that the Earth revolves around the Sun, that the stars are other suns, or that our galaxy is just one tiny island in an ocean of trillions. Why do we think this? Because for the first time in ages, the universe is misbehaving. Badly. Nasty universe. For decades, we've had a beautiful theory of the cosmos. One that explained how the universe began, what it's made of, and how it's supposed to behave. It matched our observations astonishingly well, and made us feel like we'd almost deciphered the cosmic code. But in the last few years, as our telescopes got better and our data sharper, cracks started to appear. Strange mismatches between what the theory predicted and what we actually saw. At first, they looked like silly mistakes, noise that would go away with more data. But as new data came in, the opposite happened. Some cracks got larger, new ones emerged, and our once perfect picture of the cosmos began to look less and less perfect. Of course, this wasn't new. 2 centuries ago, astronomers noticed that Uranus's orbit didn't quite follow the laws of gravity. But instead of throwing those laws away, they proposed that a dark planet was tugging on Uranus from afar. Shortly after, Neptune was discovered, exactly where the maths said it would be. But then came Mercury. Its orbit also didn't make sense, so scientists tried the same trick. But this time, no new planet showed up. The answer wasn't more stuff, but a completely new idea. Gravity had to be reimagined, and we invented general relativity, opening a whole new dimension in our understanding of the universe. So are we going through a Uranus moment, or a Mercury one? First crack. Cosmic monsters. The first signs that something deep could be off began piling up around 15 years ago, in the form of a few seemingly impossible cosmic monsters. A giant arc of galaxies over 3 billion light-years wide. A massive group of quasars spanning 4 billion light-years. A ring of galaxies 5 billion light-years across. An unfathomable wall of galaxies stretching 10 billion light-years from end to end, a whopping 10% of the entire observable universe. The list goes on. That's not all. There are also monstrous voids, vast cosmic deserts with far fewer galaxies than normal. And according to some surveys, we happen to be living deep inside one of them, a gargantuan local hole 2 billion light-years across. Where's the problem? Well, the universe is organized in ever larger structures. Galaxies, galaxy clusters, superclusters, and eventually filaments, truly gargantuan structures separated by equally enormous voids. But our cosmic theory says that these things can't get arbitrarily large. At distances beyond 1 billion light-years or so, the filaments and voids should blur into a uniform soup. And this is more than a technical detail, it's a basic pillar of all our attempts to make sense of the cosmos itself. Our understanding of the universe rests on one key assumption, the cosmological principle. This is the idea that if you zoom out far enough, the universe should be uniform, looking the same everywhere. This is crucial because it means that our limited view of the cosmos is a fair sample of the whole. That even if we are tiny creatures living in a speck of dust, we can learn things about the entire universe. Both the cosmos itself and our place in it might be more unruly and chaotic than they should be. But if the cosmological principle turns out to be wrong, we have a huge problem. Because if the universe isn't the same everywhere, we could be like ants trying to guess the flavour of a cake while sitting on its only cherry. Everything we see might just be local weirdness, a cosmic quirk that doesn't tell us the actual story of the universe. Second crack, a universe at 2 speeds. The next crack appeared about 10 years ago. It tore straight at the fabric of space, challenging how fast it grows. Every second, the universe gets a little bigger. We know this because we have different ways to measure it, and all confirm that space is expanding. The problem, they can't agree on how fast. It's like measuring the speed of a car using 2 devices and getting different results. You read 67 on the speedometer, but 73 on the GPS. One of the instruments must be broken, right? But then you check them again and again and again, and both work flawlessly. This is very much what happens with the universe. The details are messy and complicated, but they don't matter for this story. The important part is that as measurements and calculations have become more and more precise, the disagreement has only become worse. By now, the chance that this mismatch is just an accidental fluke is less than 1 in a million. The universe is literally giving us two different answers to the same question. So something fundamental must be broken. Either our measurements of the universe or our basic understanding of it. Third crack, old galaxies in a baby universe. The latest surprise is only about 3 years old. It shattered a key part of our cosmic timeline, how and when the first galaxies formed. Telescopes act like time machines. Light from distant galaxies takes so long to reach us that we don't see them as they are now, but as they were in the past. In 2021, we launched the James Webb, the most powerful space telescope ever built. And almost immediately, it began finding bright, massive galaxies so distant that they belonged to a time when the universe was extremely young. The problem? Some are so premature that they date back to 280 million years after the Big Bang, far earlier than anyone expected. Our theory says that the amorphous soup of matter that emerged from the Big Bang gave rise to the first galaxies through a long chain of mergers. Tiny lumps of dark and normal matter gathered under gravity, building larger chunks that then fused into even bigger ones, and so on. But this process is lengthy. By our best estimates, the first large galaxies should have emerged 500 million years after the Big Bang or so, not much before. But it isn't only that we've found large galaxies existing way before that. The new galaxies also seem to be too mature. Matter in the baby universe was made up almost entirely of hydrogen and helium. Heavy elements like carbon or nitrogen were only forged later in the cores of stars, which had to explode to release them. But some of these super-early galaxies contain a lot of heavy elements, meaning that entire generations of stars must have lived and died even before them. So this is like finding grown-up kids in a kindergarten. Either the first galaxies sprouted in fast forwards, or we're missing something huge about the infancy of the universe. From cracks to crisis. These problems aren't the only ones. Our theory also says that the Big Bang should have created 3 times more lithium than we see out there, a decades-old itch that astronomers just can't scratch. It predicts that dark matter should pile up sharply at galaxy centers, but instead we find gentle hills. It says that dark energy, the mysterious force pushing the universe apart, has stayed constant since the Big Bang. But last year, one of the biggest galaxy surveys ever conducted dropped the bombshell that it may have been changing over time. If true, this would overturn our current picture of the universe, its past and its future. Even things that we considered settled beyond any doubt, like the interpretation of the cosmic microwave background, are suddenly up for debate. Those early galaxies might have been bright enough to contaminate the signal. These are bold claims that require much more evidence, but the mere fact that such fundamental pillars are being discussed is staggering. So, okay, what does all this mean? Right now, there are furious battles going on. Some scientists argue that these aren't real cracks, but mirages that will disappear with time, or raw gems that will end up refining our theories. Others are more radical and say we need completely new ideas. But whatever the case, the big picture is difficult to ignore. The sense of crisis is growing. And for the first time in ages, we don't really know what cosmology will look like when the dust settles. Which is amazing, because in science, crisis doesn't mean failure. It means that the machine is healthy and working. Science doesn't move in a straight line, but in cycles, periods of calm, followed by sudden crises. When a crisis hits, experiments start giving results that don't fit existing theories. Confusion grows, and strange ideas pop up. And eventually, there is a revolution. A deeper truth emerges, and a new cycle starts over again. The universe is screaming that our story is incomplete. Whether we'll find a cosmic Neptune or a cosmic Mercury, one thing is certain, the cosmos is about to get a lot more interesting. Science makes progress because people make a plan, and are then flexible enough to change it when they get new insights. That also goes for managing your business. As your business grows, you might need the help of today's sponsor, Odoo, a suite of business apps that cover all the needs of your activity. Come along, I'll walk you through it. You know, for science. So I already selected a learning platform on the website application, but it could be anything really. I implemented it with a few clicks and directly created a new course from there. But now I have this new need. I want to sell my training online. I add the e-commerce application and I'm ready for my first sales. People love the course, and after a while I'm ready to host my first event and to meet my audience. I simply install the event app and create it in a few seconds. And Odoo offers so much more. Over 45 user-friendly applications such as accounting, project management, HR and many others, everything you could need, all centralized on one platform. You gain access to all available applications starting at $24.90 a month. This connected ecosystem saves you time and energy as all Odoo applications communicate seamlessly with one another. You can focus on what matters while Odoo improves productivity and adapts along with your needs and demands. The easiest way to change your mind and make progress. Just try it out. Now's the perfect time to grab the limited edition 12,026 calendar and get it in time for the holidays. This year's edition is better than ever. 12 vibrant Kurzgesagt illustrations tell the story of humanity's special connection with the stars. It's a year's worth of art for your home, with plenty of space to plan your days or record your adventures in 12,026. Get the calendar along with some of our other sciencey products designed with love, like our health journal, made to help you improve your fitness, nutrition and mental health in a way that fits your life, without pressure or guilt. Gift the calendar and health journal to a special burb in your life, and set them up for a stellar 12,026. Thank you so much for supporting real, human-made art.